Hello, my name is Dave Fegis, Chief Operating Officer for Moog Aircraft Group.
Hello, I'm Sheila McCartan, Vice President of Quality for Moog Aircraft. Dave and I would like to thank you for taking the time to listen to this very important message.
Moog produces world-class flight control systems that provide safe and reliable transport for millions of people each and every day. Some of those people include yourselves or even our friends and family. As a supplier to Moog, your company is part of the team responsible for products directly connected to the safety of flight. This means it is critical that we all manufacture product that conforms to design and process specifications. Remember, our friends and family are counting on us.
Our industry is on a journey towards zero defects, so when nonconformances do occur, it's imperative that our organizations act swiftly and effectively to contain and resolve them. It's Moog's expectation that our suppliers will utilize a structured problem-solving approach to drive to real root cause and implement corrective actions at a speed that will mitigate risk for you, for us, and ultimately for our shared customers. We encourage you to watch this short video with your team. It shares some key aspects of effective root cause and corrective action methods accepted by the aircraft industry as a team evaluate your problem-solving methods for improvement opportunities. If you have questions or need assistance on your journey, we recommend that you reach out to your Moog supplier quality engineer. Again, Dave and I would like to thank you for your time and attention in listening to this important message.
And we would also like to thank you for your contributions to safety of flight.
We will now begin the training on effective root cause and corrective action. As a result of this training, you will be able to implement an effective root cause and corrective action process. You will be able to define a corrective action and know why it will be requested. You will also be able to understand key aspects of Moog and aerospace industry expectations and best practices for root cause and corrective action. Let's start by defining a corrective action. A corrective action is an immediate and preventative action taken on an assignable cause to permanently fix a systemic or process-related issue. It is important not to view a corrective action negatively, but as an opportunity to improve your business and processes. There are 4 main reasons Moog would request a corrective action from a supplier. Moog receives a corrective action request from our customer to address an issue. There is an audit finding involving a gap in your processes or systems. There is a significant impact to cost or safety, or the most common reason, there is a recurring issue with your hardware. When a corrective action is requested by Moog, we expect that our suppliers will have a robust root cause and corrective action process to follow. This training will guide you through the appropriate steps for effective root cause and corrective action and prepare you to respond to any corrective action request by Moog. The steps in this process include immediate containment on non-compliant hardware, forming a team to solve the problem, defining the problem, identifying root cause of the problem, implementing permanent corrective action, performing full containment of non-compliant hardware, preventative action or look-across, verifying that your corrective action is effective, and recognition of your team. The first step in effective root cause and corrective action is immediate containment. The first action that should be taken by a supplier once a corrective action is received is immediate containment. This includes identifying and implementing the necessary actions to halt non-conforming material from entering Moog's facility. This can easily be thought of as a next part good mentality. Moog requires that immediate containment steps are identified and implemented within 2 business days after a corrective action is sent to a supplier. 3 main areas to focus on for immediate containment include containing defective material at your facility and throughout your value stream and supply chain, closing the inspection gap that allowed the non-conforming hardware to escape your facility, and ensuring all necessary personnel are aware of the nonconformity and containment actions. Once these areas have been addressed, immediate containment can be considered complete as you have stopped the bleeding. It should be noted that full containment cannot be assessed until a root cause is identified, which comes later in the process. Once the issue is contained, a team needs to be formed to commence work. Members of the team should be those within your organization that have direct working knowledge of the hardware and the issue. Examples of potential team members are provided in this chart. While the size of the team will depend on the severity and scope of the issue, a team should always include, at minimum, 2 people from your organization, as different disciplines provide different insights. Now that you've formed a team, you should step back and confirm understanding of the problem. It is critical that you and Moog have a clear understanding of the issue at hand. A vague or incorrect description of the problem will often delay the problem-solving process. You should restate the problem in your own words to confirm understanding, as the action will only be as good as the finding. Be as objective and complete as possible and make sure all references are noted, such as a drawing, specification paragraph, PO provision, etc. The problem statement should describe what the condition currently is and what the condition should be. After you've defined your problem and completed containment, it's time to start identification of the root cause through the root cause analysis. In this phase of corrective action process, your team will identify the root causes of your issue and why the issue was not detected. First, what caused the nonconformance? What allowed it to happen? What act or failure to act allowed the event to occur? Second, why was the problem not detected? How did the part leave your building? And why was it certified as conforming? There are many methods to identify root cause. An often recommended method is known as a 5 whys analysis. The 5 whys method involves asking why iteratively until the underlying cause of an issue is discovered. Begin the questioning process with the most likely major cause. With this method, you should ask why 5 times. Early questions are usually superficial or obvious. As questions continue, it becomes progressively more difficult and thought-provoking. Stop when you reach an impacting yet achievable action. A great example of this method involves the deterioration of the Jefferson Memorial, which in the 1990s had a large piece of the memorial fall off, endangering the safety of its visitors. The following 5 why analysis was used to solve the problem of the crumbling memorial. Why is the Jefferson Memorial in Washington, D.C. deteriorating? Because harsh chemicals are frequently used to clean the monument. Why? To clean off the large number of bird droppings on the monument. Why? Because the large population of spiders in and around the monument are a food source to local birds. Why? Because vast swarms of insects on which the spiders feed are drawn to the monument at dusk. Why? Because the lighting of the monument in the evening attracts the local insects. The National Park Service then made the decision to turn the monument lighting off an hour earlier. This led to a reduction in insects that ultimately ended with fewer cleanings of the monument. Notice if we had stopped at the 3rd why, we could have swept up all the spiders, but the insects and lighting would still have been a problem, and the spiders would have eventually returned, ultimately leaving the problem unresolved. By going deeper, we were able to assign an actionable cause with a permanent solution. 5 whys is a great tool to use for superficial part issues. However, for more complex system-related issues, fishbone diagrams or flowcharts may be more applicable. Once a good root cause is found, a permanent corrective action can be implemented to ensure the problem does not reoccur. A corrective action will only be as sound as the identification of the root cause. The corrective action should solve the problem found by the root cause investigation. To close a corrective action, it is imperative that there is objective evidence of change implemented within your company's processes and procedures that address the root cause. The evidence should be supported and verified by documentation that can be produced and viewed in an audit situation. Examples of good corrective actions include changes to work instructions or procedures, revisions to drawings, updates to processes, tooling, or visual guides. Your team should be made aware and trained to the changes implemented by the corrective action. The corrective action shall be able to stand on its own. Ask yourself, if the operator or team member leaves the company, does the corrective action still exist? If the answer is yes, it is a good indication of proper corrective action. It is critical that once true root cause is found, that you reassess your previous containment activities and have full containment. Additional information may be found during your root cause analysis that may affect additional parts. Examples of additional containment activities are upstream process inspection, assessing areas where products and parts may be stocked, shipped, or are in process, and assessing and recalling similar or the same parts inside and outside your organization. Throughout this process, it is essential to maintain an open line of communication to your customers of your containment plan. These additional activities are required to ensure full containment is achieved. With a sound root cause for the problem and parts fully contained, now is the appropriate time to think about preventative actions. Look across all Moog parts. Could they see the same failure? If a machine is producing a part discrepantly for one Moog part number, could it affect others? Look across all your customers. Having a special process for one customer such as Moog is a failure mode. If you perform a special process on a Moog piston, could it affect other pistons? Why wait for a corrective action request? It will be easier to take steps now to minimize risks later. Once you have carried out the actions required to complete your permanent corrective actions, you must verify their effectiveness. Monitor your processes to see if your corrective actions have fixed the problem. For example, if there were burrs on the part, are there still burrs on the part? If so, you may need to adjust your corrective action. Full verification should be performed 30 to 60 days after Moog has approved your corrective action. Making it this far in the root cause and corrective action process is hard work. The final step is to recognize the individuals that formed a team and contributed to the success of this accomplishment. Now that you have completed the process, make sure that you take the time to thank the team. Thank you for taking the time to review this video and understand the expectations that Moog has for our suppliers. You are now ready to implement this process and promptly solve issues that may arise with the hardware that you supplied to Moog. Please contact us if you have any further questions on this process. We look forward to our continued partnership with you in ensuring the integrity and safety of the hardware we produce. Remember, we're all in this together.